All right, good morning, everybody. So here is a continuation of the review for the test, which is this Friday. So I want to solve these and I want to solve finding the exact solution, not using my calculator. So here's x, want to solve for x. It's in the exponent, so it could be any real number. I'll start by subtracting 8 on both sides, and that gives me this. The base is not -2. Because the base is never negative. The base has to be positive. So we need to look at that as -1 times 2 to the x squared. You divide both sides by -1, and we get this. So 2 raised to the x squared equals 10. And you're trying to solve for the exponent, and logs are exponents. So x squared is the exponent. So that will equal log base 2 of 10. And then finally, to solve for x, you square root. And if you take the square root, you have to do plus or minus. So it is plus or minus the square root of log base 2 of 10. That is not the same thing as 10 to the 1/2, where you can swing the 1/2 around. That's a log property. What is in green, that is not the same thing. Here, only 10. The square root is only applied to the 10. And so that allows you to take the 1/2 and bring it around. In this situation, the entire square root, so the entire exponent is the square root, not just the 10. So what's in red there is our final answer. And then for number 8, you have 2 logs that you're adding, so you can multiply their arguments. So I get x squared plus 2x equals log base 3 of 15. 2 logs that equal each other that have the same base, so their arguments must be the same. That means x squared plus 2x has to equal 15, which means x squared plus 2x minus 15 has to equal 0, which means you can do quadratic formula or you can factor. And you get 2 answers, -5 and +3. Well, looking back at the original, x cannot be -5 because you would take the log of a -5, and logs have a domain of all positives. Here, you would take the log of -3 if x were -5. So -5 is not a solution. That's called it's an extraneous solution. If you check +3, that works because 3 plus 2 gives you +5, and excuse me, 3 is a positive number, so it can go directly into that logarithm. So only one solution there, 3. And number 9, you got a log that equals 3. Logs are exponents. So the exponent is 3 on the base e that results in 2x minus 5. Remember, you don't have a calculator, so the best you could do is just keep that e right there. Everything is being divided by 2, and that is your final answer. For number 10, we're solving for an exponent again. So for number 10, there's not going to be a situation where you're in number 9, or number 8 rather, where you've got a logarithm that can only receive a positive number. In number 10, you're solving for an exponent, so any real number will be okay. You subtract 5, you divide by 3, and that gives you this. So to solve for this exponent, logs are exponents. So this exponent, -3x, has to equal a log. It equals log base e, which is the natural log of 3. And then divide by -3. And that is our final answer. For number 11, that number 2 can become the exponent on the argument. And now you're subtracting 2 logs with the same base. So that means you divide the 2 arguments. And then now what? Well, this is different from number 8, where you have 2 logs that equal each other, a log on the left and a log on the right. Here, number 11, you have a log that equals a number. And remember, logs are exponents. So that number 2 is the exponent on the base 10 that results in x squared over 4. And so that's 100 equals x squared over 4. And so that's 400 equals x squared. You square root both sides, you get plus or minus 20. The negative 20 is an extraneous because that log cannot receive a negative 20. Logs can only receive positive numbers. So x equals positive 20 is our only solution. You are subtracting 2 logs, so that means you divide the arguments. And now you have one log that equals a number. So logs are exponents. So this is e to the first equals this. Multiply both sides by x. And this is similar to finding those inverses that we did last chapter. You got to solve for x. So get all the x's on one side. Factor out the x. And then divide. Number 13, you're adding 2 logs. So you can multiply their arguments. X minus 5 times x minus 3. And that is, let's see, x squared minus 8x plus 15. And you have a log that equals a number. So that log, so that becomes, you can convert it to exponential form. So 3 to the first power equals x squared minus 8x plus 15. You set it equal to 0. Either quadratic formula or try to factor it. Luckily for us, this factors, it's x minus 6, x minus 2. So there are 2 answers, 6 and 2. But now look back at the original. Do either 6 or 2 result in the logarithm not receiving a positive number? 6 is okay because 6 minus 5 is positive 1. 6 minus 3 is positive 3. But 2 is a problem. 2 minus 5 is negative 3. So 2 is not in the domain of this function, of this piece. And 2 minus 3 is negative 1. So 2 is not in the domain of this either. So 2 is extraneous. And only x equals 6 is our solution. And last, for this section, you're subtracting 2 logs, which means you divide the two arguments. And this is 3 to the 0, which is 1. Multiply both sides by x plus 6. And again, you've got a quadratic, so you set it equal to 0. And either factor or quadratic formula. Luckily, all these are factorable. Makes things faster. So x equals 4, or x equals negative 3, or both. So let's test. If x equals 4, this becomes 16 minus 6, which is positive 10. And that makes it positive 10. So 4 is good. If x is negative 3, this becomes 9 minus 6, which is positive 3. This becomes positive 3 again, because negative 3 plus 6 is positive 3. So they both work. This is a good problem to do because a lot of students think just because they get a negative answer means it's extraneous. That is not the case. Whatever answer you get, you have to plug it back into the original and see if that gives you a negative domain. And because remember, logs cannot receive a negative number. They can only receive positives.